You guys asked for it, and I'm here to deliver. You want to see helper classes for downloading files from the internet in C#. Hi, my name's Nick Cosentino, and I'm a Principal Software Engineering Manager at Microsoft. In one of my previous videos, I was showing how we can download large files from the internet and how we might manage that with streams inside of C#. There's a few gotchas that we have to look out for. Now, some of the comments on that video were that people wanted to see more work that we could do with that, how we could take it a little bit further, how we might leverage that inside of some helper classes so that we could reuse it in the rest of our code. I walked through a live streaming exercise where I went ahead and refactored all this and talked through my API design. So in this video, I'm going to walk you through the succinct version of all of those API design decisions and talk about why I went particular directions. A quick reminder that if you like this kind of content, subscribe to the channel, and you can also pay attention to those live streams when they come up, and check that pinned comment for my courses on Dome Train. Let's jump over to Visual Studio and look at some of these helper classes. I'm going to start us off with the sample application that we're going to be looking at. On my screen, I have a sample application, and if you pay attention to the beginning of the application, I am dealing with a service collection. I wanted to make sure that from the start, we could think about building this class that we could use with dependency containers. In particular, I'm going to end up needing an iHTTP client factory, and that's because in the previous video, I was just newing up an HTTP client. That's not really the direction we want to go, so you can see that I'm doing add HTTP client here. This does come from a NuGet package if I go ahead and check out the project here. Microsoft Extensions HTTP. So if you're building stuff in ASP.NET Core, I believe this will already be available for you, but you'll want to add this into your dependency container. It's just an extension method we get. And then you'll see that I'm adding a singleton, which is our stream downloader. And this is the class that we're going to be building together. From there, I'm going to go make the service provider, and then that allows us to go resolve our dependencies in that magic way, right? It feels almost magical how automatic it ends up becoming for the dependency resolution. From there, I have this URL, and someone on the stream suggested that I go to hetzner.com and go grab a sample file that we can go download. From there, basically what I'm going to do is ask our downloader to get a stream, and part of what we're implementing here is a stream where we can also get the length. We'll talk about some nuances with that, and then we're going to pass it into this other system component that I have. This is a totally contrived class. This is just to sort of mimic this situation that I had in real code. That's going to bring us into one of the big decisions for this API design that we're going to look at here. The challenge is that stream itself, the stream class, has a length property on it. If I F12 and I go into the stream class itself, this is, the stream class, and if we check, we have a length property here. The challenge with the length property is that we can't check. There's no dedicated property that says has length. I'm going to get into something in a little bit that describes some other characteristics or assumptions about these classes, but there is no has length property. The challenge with that is that because you can directly access length on a stream, you might be inclined to say, well, I'm writing some algorithm or some bit of code that needs the stream. It has a length property. I'm just going to ask for it. But if it doesn't have it implemented, it's going to throw an exception. And one of the challenging things is that when we're dealing with network streams and trying to download large files, we get a stream back that does not have a length on it. And that means that if we're passing around this stream that happens to be something that we're downloading from the internet, we can't access the length. So what can we do about that? That was all explained in the previous video, but you'll see some of the API design here as we go into our stream downloader. As I mentioned, it's going to take in this iHTTP client factory, and that's because when we call getStream, one of the first things we need to do is go create that HTTP client. From there, we're going to call this getAsync, and we're using this parameter here, response headers read. This is an important takeaway from the previous video. This flag allows us to essentially start streaming data as soon as we get the headers, and we're not going to wait for all of the content to be downloaded before continuing. This is important because between these two variations, which is using this, or when we use the other variation, which is the default response content read, when you use response content read, it will pull the whole stream into memory. It will put it into a memory stream backed by an array where all of the data is. The problem with that is with large files, you're not going to want to do that. But before we move on, this is just a reminder that I do have courses available on DomeTrain if you want to level up in your C# programming. If you head over to DomeTrain, you can see that I have a course bundle that has my Getting Started and Deep Dive courses on C#. Between the two of these, that's 11 hours of programming in the C# language, taking you from absolutely no programming experience to being able to build basic applications. You'll learn everything about variables, loops, a bit of async programming, and object-oriented programming as well. Make sure to check it out. We're going to use response headers read. This is going to allow us to get a stream that is not a memory stream, and from there, we're going to try to essentially get the length, and that's where the other complication comes up. This just gets us a stream. If we were to check this at debug time, doing these two things together will have a network stream, but try get content length is something that we wrote in the previous video, and that's going to check the headers off of content and make sure we have content length. We will parse out the long value that is representing the number of bytes. And that way, once we get to this part here, line 88, we're at a point where we have the length and a stream. Now, this is where I want to talk about some of the API design and why I'm returning, if we scroll back up here, this stream result type. I made stream result here, and it has a stream and a long length. One of the reasons that I'm doing this and not just using a stream that has a length sort of already on it is because there's a bit of a complication in what Microsoft recommends for the stream type. Apparently, and I found this out on the stream, I'm going to switch over here to my browser, and there's a Stack Overflow answer here that is basically answering someone's question about stream length and can seek. When you have can seek set to false, so you have a stream that's not seekable, and for comparison, a memory stream is seekable because we have the whole thing in memory. We can go any point on it. But a network stream, and there's other various streams, are not seekable. So you can't just start downloading something and say, oh wait, after 2 gigabytes of downloading, let me just kind of scroll back a little bit in this stream. You can't seek around. So it's a non-seekable stream. But what Microsoft recommends from MSDN here, if a class derived from stream does not support seeking, calls to length, set length, position, and seek, throw not supported exception. The reason that I don't like this is because I have a particular situation where I do not care about seeking whatsoever. The situation I have in my own code, which is why I'm creating all of this, is that I need a stream and I just want to know the length. But because of this type of stream and the recommendation from Microsoft, we are not supposed to use the length of the stream if we cannot seek. If I go back to the code now, that's the reason why on the stream result I am returning a length separately. It's also nullable. So let's go back down and look at the return part here. When we're returning, we're always going to pass the stream back, but when it comes to the length, we're checking if the stream is seekable, then we'll return the stream's length. Otherwise, it's a stream where we don't have the length. If we look a little bit above here, we have a return when we did get the content length, and we'll pass that back separately. We either have the length from the content length, or we'll check if it's seekable. We'll give the length of the stream back, otherwise there's no length. When it comes to using this API, it feels a little bit clunky for a few reasons. So let's go up and explore the usability of this. And when I say usability, I want to talk about the ergonomics of how it feels to call this API, use the result, and kind of what the code feels like afterwards. If we look at the stream downloader here, this is where we're calling getStreamAsync. We get this stream result object. If I hover over it, you can see that it is a stream result, which is great. Now, we have this component, and I didn't really explain it earlier, but do something would have to take in a stream and a long length if we wanted to do something with the length. And this should read something like this. The reason that we would have to do this is that according to the Stack Overflow answer that we saw where it was quoting some Microsoft MSDN documentation, we can't trust the length on the stream class. We can't trust it because if it's a non-seekable stream, we should expect that length will throw an exception. Again, I don't really like this, and we're about to see why. It means that I'm going to have to pass along a dedicated length. Right? I can trust that whatever length is coming in here is going to be right, and I can't trust the length on the stream. So doing something like stream.length, I can't do that unless I check can seek first. If that's the case, the way that I've done this, we're not supposed to be populating the length property if it's not seekable. Whole bunch of stuff that doesn't feel good about that, and it would mean essentially that all of my downstream code that needs to use both the length and the stream literally needs to be either provided separately like this or packaged together in an object that I can go pass around instead of just using the stream. To me, that feels pretty gross. So in this example here, this mocked up little dummy class isn't really doing anything, but the point was that I have code in my own projects where I need to use the stream for something, but I also need a length, and I need to be able to trust that length. So unfortunately, this is how this would look. I don't really like the ergonomics of that. It feels gross to have to pass both of these around. And if we look at how we're calling this, essentially, if we want to call do something, we need a stream, but we also need to have a length. And what we would have to do is a null check, which also feels really gross. You can see that I'm using the null coalescing operator here with the double question mark to check, like, if the stream length is not null, we'll pass it in. Otherwise, if it is null, I need to throw an exception right here. We can't continue on because do something requires a length. To me, all of this feels a little bit gross. The fact that I have to pass 2 parameters into do something just isn't a great fit for me. And the other part, if we scroll back down, this nullable long length, also not a big fan. This is where I turned to the viewers on the stream and I said, I think that I want to show you the other way that I would want to do this. And it means we're going to break some of the rules if we go back to Stack Overflow. If we break this rule here and we say, look, we have a stream. It does not support seeking, but we are still going to populate the length. I think personally that it's going to make the code that follows a lot cleaner to use. So I wanted to explore it. On the stream, we walk through both, and you're about to see the other variation of this and how I feel like it cleans up the API. But I'll leave that up to you, and you can leave a comment below based on your decision and what you feel works better. So in my code now, I'm going to flip over to the other implementation of Stream Downloader. Okay, this next variation is going to be very similar, but there's a couple of differences, in particular around the return type. So stream result is still an object that I'm using as the response type, and you can see that instead of having the length that's nullable in the stream result, it just has a flag as to whether or not it has a length on it, because this method can still return a stream that does not have a length, and that's the case if we have a network stream and there are no headers that set the content length. We need a flag for that, and that's what I have here, and it's just going to return a stream as well, packaged along with it. The rest of this code is very similar, so it's not really worth explaining all that we just saw here, but what is different is that when it comes to returning things, I'm going to make a dedicated stream that has a length associated with it. And this is a custom class. It's almost entirely pass-through methods, but if we jump into it, what is different about it is that it takes a stream as a stream that it's going to wrap, and that's where all the pass-through methods, you can see here, right? The pattern you see where it's like arrow pointing to the same thing, these are all pass-through. What's different, though, is these two things here, and really the important one is the length. So I'm just saying, look, I'm creating this stream, and I'm telling you what the length is. I don't care what the inner stream says it has for a length. I'm telling you what it is. The take ownership part is just when it comes to disposing. So if I scroll a little bit lower, we can see that when we go to dispose, if you've said, I would like this stream to take ownership, then in fact it will dispose of that inner stream that it's wrapping. Otherwise, not a lot of interesting stuff going on with this stream. This is just the part that breaks the behavior with can seek, right? Because can seek could be false, and we are still saying, look, I'm never going to throw an exception when you call length. I'm just going to make sure that we're returning the length that was passed in. So yeah, that does kind of break the rules, but we'll see why I feel this makes it feel a little bit cleaner. One of the returns is that we go create that stream with a known length. We have this content length coming out when we have the header. Great. And then when we go to make this, we give it the content length passed in, and this is just returning those two things packaged together. Otherwise, when we go to return, we have a stream, and we don't have to wrap it with anything. And we don't have to wrap it with anything because we might not know the length of it. The other thing that we're doing here is that we have a can seek. Now, as I'm reading this, potentially what we could do is modify this a little bit further and say, if it can seek, we might be able to wrap the whole thing up with another stream with length. We could go do that. But basically, if it can seek, we know that by definition for what we saw on Stack Overflow, if Microsoft is adhering to this, if it can seek, it will have a length. We should be okay technically. When it comes to calling this thing, what's that going to look like? If we scroll back up, we can see that this code no longer compiles, and that's okay. We're going to get rid of it, but we're going to see what we can do instead. I have another method call that I'm going to be using here, and it looks pretty gross, but we have to go change something as well on the system. And this is the part that I wanted to illustrate, because this part, I didn't write my code this way. I didn't want to have to pass a stream and a length around separately. I said that feels kind of gross and kind of silly. I just want to be able to trust whatever the stream has for a length. This is just one parameter. It's not two things passed around together. This just feels way better to me. What I wanted to do is this kind of thing, and basically you can see that it says stream with length in particular. I am forcing a caller to pass me this type. There's a reason for that, and it's that I need the safety of knowing that I can ask for this length. That means if you have another stream that is seekable, you would still have to go wrap this with a stream with length, and we're going to see why this looks a little bit gross, because if you check out here, when we go to call do something, this code looks pretty nasty, right? I get the stream result back, and I ask for the stream, but we have to go wrap it with the stream with length, and you're probably going, Nick, how the heck is this any better? And I agree, this feels pretty gross so far, but there's some improvements we can make. When we go to check for the length itself, we have to go see on the result, does this thing have a length or not? If it does, we can ask for it. Otherwise, we're stuck here throwing an exception. When I did this on the stream, because I was doing this live and trying to see like how things look and feel, I repeated myself on the stream and I said, as soon as I find myself writing throw exception, I find generally that I'm not structuring code in a way that I'm happy about. I like to use more of a result pattern. In a lot of my code, you'll see it's like all the methods are called try to do something, and we get a result type back. If I have to throw an exception like this, not a good feeling. But the reality is that this thing requires a stream with a length. If we don't have one, we can't continue. I don't like throwing exceptions. What's the way that we work around this? Well, I want to go clean this whole thing up, and I think we can do that with some extension methods. What we're going to look at now is some extension methods at the bottom of this whole file. We'll jump down here. Let me go collapse this guy. We don't have to look at the details. And we're going to look at stream extensions here. I have this extension method called try as stream with length, and it's going to operate on any stream that we have. And I wanted to give a shout out for folks on YouTube comments. Thank you for suggesting this attribute. We'll look at this in a moment. Basically, this extension method will say, if we're talking about a stream that already is of this type, we're just going to cast it and return it. We don't have to do anything fancy. No point in wrapping a stream with length inside of a stream with length. It's just silly. So we'll return the same thing. Then otherwise, we're going to do a couple of things here. I'm going to talk about this try catch in a moment, but we're going to see if this stream is seekable, we are going to create a stream with length. And that's because we're going to use that rule that we saw on Stack Overflow, where if we have a seekable stream, it means that we should be able to read the length, and this will not throw an exception. So we're going to take that here. I think technically this actually needs to say that it does need to take ownership, so that's my apologies. We are going to wrap this thing up and return a stream with length. Now the last part is that when we hit this end part of the code here, we're going to have no stream with length. We're going to return false because this thing is not able to go from a normal stream to a stream with length because there's no length. The try catch is just in case that someone breaks this rule where can seek is set to true and there is no length for some reason, right? If that's the case, we are going to catch this. I know this is pretty gross to see an empty catch block, but what I was explaining to folks on the stream is that generally when I write a method, if it says try out the front of it, you should not have to look to catch exceptions as the caller. This is just a safety net to say, hey, look, if someone did this, we could go, carry on, return false. You might want to have a debug mode for this. You could use conditional compilation to put this only in debug, to throw exceptions, and in release mode it's safe. Up to you. I'm just kind of showing you how I was walking through this. But the point is that now that we have this method, it does make it a lot nicer to go call. So let's scroll back up, and basically we can comment this code out because I agree, that's pretty nasty looking. But look how succinct this version is here. So we would ask the stream coming back from the result to try and get it as a stream with length. If it works, then we're going to continue on. If it doesn't work, we're able to go return. We could go throw an exception ourselves. But the point is that we have control without throwing exceptions, because down here, forcing an exception to be thrown, in my opinion, if that's not meant to crash the entire application, that's not really going to be something you want. And because you cannot control what the server side, unless you control the server that you're trying to download the files from, if you can't control the server side, they don't have to put the content length header on there. They should, that's the recommended thing to do, but they don't have to. And if you expect that that should crash your whole application, then by all means do this kind of thing. Otherwise, we need to make sure that we can continue on and handle that error case accordingly. In my opinion, this was a way to go clean everything up with the extension method. And the other part that I wanted to come back to was that attribute. And this is just a little bit of a nuanced thing here, but if I go ahead and I copy this attribute out, so we don't have it there, if we scroll back up, you can see on line 23, do something is saying, hey, look, something's fishy about this stream with length. If we hover over it, Visual Studio's telling us possible null reference argument for parameter stream. It's impossible if we go look through this code because we can see that basically we always populate this out parameter with not a null value as long as it's true. But the compiler's not able to figure that out, so we have to give it a little bit of guidance, and that's what this attribute does here. So if we put that back on and I scroll back up, you can see on line 23, it now knows when I hover over it, it says stream with length is not null here. So we're giving the compiler a little bit more information about our API. So in summary, these are two different API variations I made for a helper class. This thing works if we go to ask for it off of the dependency container. So this works with iService collection as long as you have an iHTTP client factory registered on the container. Otherwise, you can go build this thing manually, passing that in. And if you wanted, you could have a variation of this where you don't have to pass that interface explicitly, but you could have a way to make your own HTTP clients inside of that as well. The two big differences and variations here were, one, following the MSDN suggestions around the stream class, can seek, and the length property, which forced us down this path of having to provide those two pieces of information on different API calls downstream. Or the second implementation was basically breaking that rule and saying, hey, look, we have a stream that's not seekable, but I do happen to know the length, so I'm going to provide you the length if you ask for it. In my opinion, this feels not so bad. I would much rather be able to access the length if we know it and not force myself to basically pass two pieces of information everywhere. If you enjoyed this and you want to see more on sort of this investigation and this type of thing, I want to have some benchmarks ready to show you the memory usage between the two different header formats we looked at. So when you're interested in seeing that and it's ready, you can check it out here. Thanks, and I'll see you next time.